Hey there, hi there, ho there, welcome back. FYI, if you see me perspiring and sweating a little bit, someone at EMCC turned off the air conditioning in the building. Thanks. Thanks a lot. But I persevere. Let's get into this. So we talked about igneous rocks. Now let's talk about sedimentary rocks. Kind of look like this. To be honest, to me, in the branch of geology that I am in, and just in personal interest, sedimentary rocks, they're not all that fun for me to look at. However, in the context of historical geology, they tell the best story, most likely of almost any rock. Each different rock tells a different story. Sedimentary rocks definitely tell the most of the story. So now we're in this kind of branch of the rock cycle. So we have some existing rock, whether it's igneous or metamorphic, more on that next section. And then these rocks are weathered, which means broken down. And that could be physically via the weather or chemically broken down. They're broken down into pieces called sediment. That sediment is transported. That sediment is then deposited somewhere. And then over time, as that sediment builds up, it compacts together. Minerals cement that broken down rock material together, and then you get sedimentary rocks. So again, sedimentary rocks result from the lithification of sediment. Lithification is a fancy word that just means turns to rock. So sediment turns to sedimentary rock via a process called lithification. So sediment originates, so we got to start with sediment. All right. So sediment originates when some other rock is broken down, either physically or chemically. That's weathering, breaking down. And then that material is transported via erosion and then deposited somewhere. Other ways sediment can accumulate is that it precipitates out of solution, meaning in water you can have dissolved sediment. If you, maybe not in your house, but if you've ever seen a shower with that kind of white crusty stuff around it, that's actually sediment that's in water. It's called hard water. Most people around Phoenix have hard water, unless you have a water softener in your garage or somewhere in your house. But what that is as the water from the shower head dries up, after you take a shower, it leaves behind the sediment. That's sediment that's in solution that has precipitated out. That's what that means. Or organisms can also extract sediment from solution as well. So that's how sediment can accumulate. So again, we need to break down existing rock, that's weathering, and then we need to move, and so when we break it down, the stuff that's broken off is called sediment. And we have to transport that as sediment, and that's called erosion. Water, wind, gravity, glaciers can move sediment. So weathering and erosion work together. They're two different things, but they work together. Weathering and erosion. Oftentimes, you'll just hear the term erosion, and people use it to kind of mean both things. No, incorrect. Weathering and erosion. So we have sediment that's been broken down from some original rock, whether it's igneous, metamorphic, or even other sedimentary rocks. That material is eroded and deposited somewhere. Now we need to undergo the process of lithification, converting sediment into sedimentary rocks. That occurs with two steps. Step one, compaction. You take this sediment, and as you pile it up and pile it up and pile it up, the sediment on the bottom is feeling compacted. It's feeling the pressure from all that other sediment above it. So the sediment is being compacted. So compaction is the first step. The second step is cementation. So not only are we compacting the sediment, but oftentimes, sediment is loose. There's space between all of these little sand grains and pebbles and stuff. That's what sediment is. So there's space in there, and water can make its way in there. And oftentimes, water has this dissolved mineral content in solution. So when the water evaporates away, it leaves behind that mineral content as a cement that cements all the grains of sediment together. So now we went from sediment to sedimentary rock. Oftentimes that cement can be calcium carbonate. That's a very common cement. Silica can be a common cement. Iron oxides and hydroxides a little bit less common. So visually what's happened? Okay, you have all these individual pieces of sediment material that's been broken down from larger rocks. It could be little pebbles, it could be grains of sand, those are all sediments. You take that material and you compact it together. There's still space in between these grains of sediment, and oftentimes water can make its way in there, and that water might have dissolved sediment in there, dissolved minerals in there. As the water kind of evaporates away, it leaves behind those binding cements like calcium carbonate, and so it cements everything together into a rock. So you went from sediment to sedimentary rock with 2 steps, compaction and cementation. There's 2 categories of sedimentary rock. Detrital sedimentary rocks, and those consist of rocks with solid particles that came from other pre-existing rocks. That sediment that's weathered and eroded off and broken down from pre-existing rocks is called detritus. So when you break down and erode sediment that becomes sedimentary rock from existing rock, those are detrital sedimentary rocks, sometimes known as clastic sedimentary rocks. And then another process is chemical sedimentary rocks. These derive from minerals that were carried in solution to lakes and seas. So in water, in streams, again, there's dissolved chemicals in water. And they make their way to a lake or a sea, and even microscopic sediment begins to settle out as the water maybe evaporates away, leaves behind that sediment, becomes sedimentary rock. It's a chemical sedimentary rock when material is precipitated out of solution. There is a subcategory of chemical sedimentary rocks called biochemical sedimentary rocks, in which activities of organisms play a part as well. So sediment is typically classified, specifically detrital sediment or clastic sediment, is classified by the size, how big the piece of sediment is. We call any piece of broken down rock that's 2 millimeters or larger gravel. We break it down into subcategories, but a gravel is 2 millimeters or bigger. So 2 millimeters is about this much, between the space between my fingernails there. So anything that size or bigger is considered gravel. From about that size to smaller is sand. So sand is not a particular sand is not derived by the content of the material, but it's just the size of the sediment. So sand is just a smaller sediment size, broken down rock and mineral material smaller than gravel. Smaller than sand is something called silt sized particles, and smaller than silt is clay sized particles. They're very, 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 very small. If we were to zoom in on sand, silt, and clay, imagine I took one little grain of sand and I zoomed in on it, all right, and to where like I looked at it under a microscope and a grain of sand was this size. Comparatively speaking, you can see how small silt and clay are. All right, sand is small, right? When we talk about something that's small, we talk about a grain of sand. Well, silt and clay are even smaller. So when you compact and cement this detrital sediment, you get detrital sedimentary rocks. Again, these are composed of fragments of particles known as clasts, and we talk about these types of rocks having a clastic texture. And these rocks are defined by the size of the clast, the size of the sediment. So 2 millimeters or bigger, those are gravel. We call that coarse texture or coarse grain, coarse sediment. And if a sedimentary rock is made up of gravel 2 millimeters or bigger, and the gravel is rounded, we call it a conglomerate. If it's made up of sediment that's 2 millimeters or bigger, but the gravel pieces are kind of sharp and angular, we call it breccia or breccia. Sand-sized particles make sandstone when it lithifies. Mud-sized particles make siltstone. And then even smaller, which we also kind of still call it mud, makes shale. Sometimes we kind of break up these a little bit, and there is kind of in between sandstone and siltstone, there might be something called mudstone. And in between siltstone and shale, there might be something called claystone. But in general, based on the size of the particles and the shape for these first two, determines the type of sedimentary rock that is derived. So Gravel, if it's rounded, makes conglomerates. Sand makes sandstone. Silty mud makes siltstone. Clay mud makes shale or a number of other things. Okay? So the sedimentary rock is classified based on the size of material of sediment that it's made up from that was compacted and cemented together. This might be one of the most important things in this unit, in this lecture. Most of the world's sedimentary rocks form as layers on continental shelves in the shallow parts of the ocean. The continental shelf is the part of the continental crust that extends out from the continent. It's still continental crust, but it's under the ocean because weathering and erosion and wave action kind of ground it down a little bit. So the continental shelf is the part of the continental crust that's just under the ocean. However, I'll say it again, most of the world's sedimentary rocks form as layers on these shelves in the shallow parts of the ocean. You get water taking sediment, depositing that sediment in these shallow parts of the ocean. That sediment builds up, compaction, cementation occurs, voila. So when you're looking at sandstone or shale, for example, like if you go to the Grand Canyon, there's layers of sandstone and layers of shale and a number of other things. So I would say, I don't know, 8 times out of 10 when you're looking at a sedimentary rock, good chance that it formed from sediment that was deposited in the shallow parts of the ocean. So now, think about that story. I'm at the Grand Canyon. If these layers of rock were formed by sediment that was deposited in the ocean, that means the ocean covered that part of Arizona at one time, deposit that sediment, sedimentary rock eventually formed, etc., etc. We looked at that a little bit towards the end of Unit 2. So, very important, very important. Again, 7 or 8 times out of 10, you look at a sedimentary rock, ocean. Oh my gosh, there was an ocean here. Igneous rocks tell you volcanoes were there, volcanic activity. Sedimentary rocks can tell you oceanic activity was there. And then we have chemical sedimentary rocks. Again, they're derived from material that's carried in solution to lakes and seas, where the water kind of evaporates out, leaving behind the sediment. So this can result in different textures. You can get a bit of a crystalline texture in this case. You can get a clastic texture as well, but it'll be more biological, shells kind of cemented together. So chemical sedimentary rocks, it's more based on the composition, somewhat the texture, the grain size, but more so on the composition. Of all of these are more clastic in nature, but they're still chemically derived sedimentary rocks. These are all types of limestones. These are all evaporates formed by material evaporating away. Limestone is formed kind of a little bit different process. And then we have, bituminous coal, which is a biochemical sedimentary rock. So coal is actually derived from plant material, ancient plant material. You have trees and plants and swamps. That material, leaves fall off, die, and they fall to the bottom of a swamp. That organic material builds up, much like sediment. Compaction, cementation, that's where coal comes from. It's actually from plants. Coal is actually fossilized plant material. So again, chemical sedimentary rocks, you get sediment-rich streams that water into a shallow lake. The water evaporates away, leaves behind the salt. Now we have a chemical sedimentary rock. Like the bottom of Death Valley. That's the place I licked. Kind of the same thing depending on the ocean and ocean levels. You can get kind of that same thing if ocean basin kind of gets, if the water gets too low, maybe ocean water gets stuck here, the water evaporates away, leaves behind, for instance, salt, and that becomes then a chemical sedimentary rock, which coming back, rock salt is a chemical sedimentary rock. All right. Yeah, I think that's it. I think there's just One more video to go, so stick with it. I know this has been kind of a longer unit, but stick with it. Trust me, the units get shorter as we go on throughout the semester. I'll see you back here in just a second.